We can find the matrix inversion by using the LU decomposition method. For example, let's say you have a system AX equal to B, and if the A matrix is given by this, how to find the inversion of the A matrix? You should know that when A matrix multiplied with its inversion, you should obtain the identity matrix. So in this case, when we compare this equation with the equation here, so we can let X equal to your inversion A, which is this, and your B matrix is the identity, which is this. So for a 3 times 3 matrix, then your identity should be like this, where you have the diagonal here to be equal to 1. Let's substitute these two matrices inside this formula, and you should have this, where you have the A inversion equal to your identity. And we assume the A inversion to be the unknown X. So unknown X at the first column, second column, and third column. Similar to the previous example, you can treat this equation to be multiple input and multiple output. For example, you have the system represented by the A matrix here. So the system is to remain constant. Then if let's say you give your input X at 1 for the first column here, then you obtain the output to be this 1 0 0. So this is your first output due to your input X1. Then you continue for the X2, which is this column. So this is the vector for the second column. Then you obtain the vector for the second column here, which is 0 1 0. And if you continue, if you apply the input at the third column here, then you obtain the result output at third column as well. So you see you have 3 input into the system and you obtain 3 output from it. Let's perform the LU decomposition to find the inverse matrix of A, which is this term. So by using your output, which is the identity, and also the system matrix, then we are going to find this. So first of all, you find your LU from your A matrix. And since this A matrix is the same with the previous example, then we can use the same answer that we found in the previous example for the L and U matrix. Basically, this is the factor that we use in the Gaussian elimination during the forward elimination process. And this is the Gaussian elimination result after we perform the forward elimination. In the second step, we perform the forward substitution to obtain the unknown D. And then we substitute inside this equation, and in the step 3, we perform the backward substitution to obtain the unknown X, which is our inversion. In the step 2, you perform the forward substitution by taking the first row multiplied with the column here equal to this answer. And then from this equation, you obtain the D11 equals to 1. And you repeat for the second row, multiply with this column equal to 0. And then you obtain the answer for D21, which is this. So you continue for the third row, multiply with this column equal to 0. So from this equation, you can find your D31 equal to this answer. And if you repeat this 3 row with the second column here, you can find the answer for D12, D22, and D32 to be these 3 answers. Repeat the same procedure by multiplying these 3 rows with the last column here. Then you should be able to obtain these 3 answers. So with that, we can continue. Substitute the D answer inside this equation. So this is your D matrix. And over here, you have your U matrix here. So we are going to solve the x by using the backward substitution. So for the backward substitution, we take the last row here, multiply with the first column, then it should be equal to this answer. Then if you solve the equation, you should obtain the x31 equal to this answer. And you take the second row and multiply with the first column equal to this answer, and then you can solve the x21 equal to this, and you continue for the first row, multiply with this column, you get 1, and then you solve it, you obtain x11 equal to this answer. And repeat the same procedure by multiply these 3 rows to the second column here, you obtain this answer, and then continue with the last column here, multiply with these 3 rows, you obtain another 3 answers here. So with that, you obtain this solution, and this solution is your inverse matrix for the A. To check if this answer is correct for the inverse matrix A, we can substitute it inside the original equation. Then if you check the multiplication on the left hand side is equal to the right hand side, which is an identity matrix, then we are saying that this answer is correct.